Hi class. This video is about solving exponential equations. In particular, solving the exponential equations that are of the form when we cannot get the same base. Remember, if we have a simple exponential equation, we can get the bases the same on either side of the equal sign, and then we can just cancel the bases and continue to solve because exponentials are one-to-one functions. But sometimes you will not be able to get the bases the same because the numbers just don't share a common base that we can raise both sides to the same, by the same base to different exponents. In that case, we have another process. Your first step will be to isolate the exponential function. And by isolate, I mean solve for the exponential function. Your second step will then be to convert the equation that you have to the equivalent logarithmic equation. Remember, we can convert back and forth from exponential form to logarithmic form and back again. And then lastly, once you've converted, your variable, which is in this problem, currently the variable is like trapped inside of the exponent. Once you convert to a logarithmic equation, your variable won't be trapped anymore. It will be accessible to you, so you'll be able to solve the equation using some algebra. So let's look at this example. Step 1, isolate the exponential function. So step 1, this piece right here is the exponential function. I'll abbreviate that exp-func. That's the exponential function. So if we were to isolate that, we would have to divide both sides by 7. And if we do that, we'll have 2x minus 3 equals 17 over 5. And now the exponential function is isolated. It's all by itself on one side of the equal sign. So we're ready for step 2. So remember, step 2 is to convert to the equivalent logarithmic equation. So the way we do that is the base becomes the base of the log. This number will become the argument of the log. It's what goes inside of the log. And then the exponent is on the other side of the equal sign when we do this conversion. And now look, your variable is no longer trapped up in an exponent, so you can solve this equation for x. And that's step 3. So we can do that just by adding 3 to both sides. That's simple enough. And now you can evaluate this with your calculator. Just remember that the way we would do that, we don't have a log base 2 button on our calculator. So you would have to use the change of base formula using either the common log, like this, and then adding 3. Or you could use the natural log. Either one will actually give you the same answer. So that might surprise you, but it really doesn't matter which one you use. Either of these, oops, we have to add the 3, will give you your answer.